the gravity of the time is such that every new avenue of peace, no matter how dimly discernible, should be explored. Never before in history has so much hope for so many people been gathered together in a single organization. You will provide a great share of the wisdom, of the courage, and the faith which can bring to this world lasting peace for all nations and happiness and well-being for all men.
So we are here today with Allan Carson on Titans of Nuclear. Allan is a project manager at the World Nuclear Association. Allan, welcome to the show.
Thanks very much, Brett. Good to be here.
Yeah, so let's get started by just learning a little bit about you first. Tell us, where'd you grow up?
Oh, well, as you can probably tell by my accent, I grew up in Ireland, specifically Northern Ireland. And I grew up in a farming community. My parents worked, my dad worked as a mechanic, and my mother worked in healthcare all her life. So there's no engineering or nuclear background there. And then I left Ireland and went to university in England to study process and chemical engineering.
And just because, not to just pass over the Ireland thing too quick. So did you grow up in Northern Ireland or South Northern Ireland, or where exactly?
West Northern Ireland. So I live pretty much 20 minutes from the border with the Republic of Ireland.
I was going to ask, and when you were growing up, was anything going on? What years was this?
Yeah, this was going back from, I can't remember the exact years, but going back maybe 30 years now. I would have been a child, but I still remember there being quite a lot of military presence around. There was no border checks at that time. But I still remember a lot of military presence around, quite a lot of training happening in the area, et cetera, et cetera. And there was still quite a lot of angst in around the local area, shall we say.
Yeah, and probably a bunch of stories from your folks also, huh?
Plenty of stories, yes, that I'll not go into in detail right now.
Yeah, but I am curious how that maybe, if you've ever had a chance to kind of reflect on that and kind of like piece it together with the rest of your life and kind of where you went on. Do you think it had any influence, or? I
think it made me quite strong-willed, and I think it made me quite resilient to challenges in my life, and made me quite determined to sort of do something, to sort of move myself forward, not go around in a sort of a cyclical, nonsensical argument. And so I think it probably did those things. I've not reflected on it too much, but if I was asked the question, I think those would be the key areas.
Yeah. Okay. So tell us. It's always great to get some perspective on who the person is. But tell us, what did you want to make of yourself?
Well, to be brutally honest, Brett, I didn't know.
Yeah.
I still am not entirely sure, if I'm being truly honest. I sort of take it one sort of day at a time, and try to deal with the challenges in front of me. And I like fixing problems. So engineering came quite naturally to me, as in, I was always good at the sort of the maths, physics, chemistry side of school. And so engineering became a sort of a natural transition from that. And so I went and sort of studied chemical process engineering for 4 years in Newcastle.
Where is that exactly?
Northeast England.
Okay.
Cold in winter. And then, that degree very much orientates you towards the oil and gas industry.
Okay.
It's very, refining, distilling orientated. That's very much sort of where a lot of that training and coursework was going. And then when I finished that, the natural progression was going to be into petrochemicals industry, but I ended up taking a job with what ultimately became Jacobs, an engineering consultancy company, because I wanted a slightly different perspective, and I want the opportunity to work across different fields, not necessarily pigeonhole myself too much.
Yeah, give yourself options, huh? Yeah,
exactly, because you don't know what you're going to like or what you're not going to like in 3 years' time. So it's about giving myself options, and then that's kind of really where I got introduced to nuclear power and the nuclear industry. And in that, I think, as most people of my generation in the UK will have started off working in some form of decommissioning at Sellafield and all the projects that are associated with that and with waste management, etc.
Because that's where the money is. A lot of government money goes into it. So that creates a lot of jobs, and that creates a lot of training opportunities, especially for up and coming engineers.
Well, yeah, exactly. And to be honest with you, when I was starting my career 15 years ago, the UK barely had a new build program. It was very fledgling at that point. There wasn't a lot of work in it, and nobody was really sure where it was going, and they hadn't built anything for 15, 20 years before that. So the decommissioning of nuclear was the only thing going in the UK at that point.
Yeah. And what kind of decommissioning activities? Like, can you just kind of like set the scene for us? Like, what happens?
What happens? Some people would say nothing, but
yeah.
But in truth, quite a lot happens, and a big part of it is a lot of the planning. It's about the de-risking of getting the fuel off the site, because once you can get the fuel off the site, then you can then sort of put it into care and maintenance time, and you can start to strip things out with much more speed, basically. So it's the kind of things of looking at how you take waste out of certain places where maybe that waste shouldn't be, process that waste, and manage it and take it off site. And when I'm talking about waste, I'm not talking about spent fuel here. I'm talking about sort of the other tailings that have come out of legacy nuclear sites in the UK.
Yeah, that's what I was just going to ask you. I was going to ask, what form is it even in?
Some of it is just bits of steel. Some of it is
just on the ground, or it's already in buckets.
No. They're normally put inside sealed vaults, and then filled with water, etc. And sometimes it's in resin form, sometimes it's in liquid form, sometimes it's in slurry form. And so there's all the challenges to how you get it out of where it currently is, how you end up processing it, what the waste products from that are going to be, how you're then going to end manage it, how you're then going to transport it to its final disposal site, etc. And those are the sorts of projects that you normally get involved in, or certainly that those were the early projects that I was involved in the nuclear industry in the UK.
Got it. Okay, so what happened next?
Well, what happened next was Jacobs won a contract to provide the environmental case for the GDA for the AP1000 in the UK. And I was very interested because through the decommissioning work, you start doing a little bit of research, you go down rabbit holes and you think, okay, hang on, this industry is quite interesting. It would be good if we could build some new ones. So when that opportunity came along, I jumped at it with two hands, got myself involved as a relatively young engineer at that point, doing simple mass and energy balances, looking at the waste volumes, building up the environmental case, and then looking at the emissions, etc. Supported writing the chapters of the environmental case, and supported the meetings with the environmental regulator in the UK, the Environment Agency. And then I got a bit of a crazy opportunity, really, in that Westinghouse wanted somebody as a sort of a UK liaison for their project to go over to the US. And so again, jumped at it with two hands.
And when you say you got that opportunity, how? Like what? Like did someone email you? What happened?
No, I proposed it. Let's be clear. I suppose, in fairness, I thought it was because they were starting to struggle with sort of understanding of what the UK regulators were actually asking, because there's a different. We all speak one language, but we don't really.
When you say we all speak one language, you mean we all speak English,
we all speak English.
We all mean different things when we say it.
Correct. Yes. And you know, I've got some stories about that as well. But they needed, the UK regulator requires a much more of a story. You know, I got the impression at that stage that when you submit a response to a question to the NRC, it's pretty much just facts and figures. Here's the answer. Job done. The UK regulator requires much more of a, here's the background. Here's why we've done it, and here's what with the decision process we've gone through. This is why we made these decisions. This is the outcome, and this will be the final design decision, etc. And the environmental regulator and the safety regulator are one and the same to some extent in that respect, because for the GDA, they actually form a joint office, and they work hand in hand. So there's one submission goes to both essentially.
And but let's not brush past this too quick, because I think this is a great lesson learned that we can talk about to help others navigate the UK regulatory process in the future. The differences between the US regulatory culture and the UK regulatory culture. So, are there any other examples maybe that you can dive into where, like, the US way of doing it, like didn't work?
There's nothing I can go into in too much detail. What I can say is there's a number of examples where, and I'm actually writing a report right now about different interpretations of regulatory requirements that delves into not just US to UK examples, but also France to Finland, France to UK, Russia to Hungary, etc. It delves into the regulatory mindset and framework sets up a set of interpretations that, while consistent with the IAEA safety guidance and standards, lead to very different design decisions at the end point.
Like what?
INC systems off the top of my head.
Yeah.
You know, if you pick the EPR, the INC system in France is different to the one at Regulator, and it's different again to the one at Hinkley. Waste management systems, between sort of how the waste gets managed and processed in the US and or Japan to how the UK and or France would want it to be processed and managed, and the time involved in that, and also what the end product needs to look like. The famous one is the thickness of the pressure vessel between Russia and the US. I think it's 19 or 25 centimeters is the difference. So yeah, both are considered safe in their own respective territories, and these are the challenges that we've got when we move reactors from one territory to another territory. The requirements, and it's not just numbers and figures that are different. Because in a lot of regulatory regimes like the UK, you don't have set numbers and figures. What you have is an expectation to demonstrate it's as good as it can be. And that can lead to some challenging conversations, because, you know, from the US perspective, and we'll get into sort of I had some experience with the Japanese bringing the ABWR to the UK as well. You know, they have a design that's safe and operating. And why they're having to change that, because the regulatory requirements or expectations are slightly different, is a very challenging conversation to have with companies.
And sorry, you said something that I want to dive into, just in case it's one of those language things that we talked about before.
Sure.
You said as good as it can be. When you say that, what do you mean? Do you mean that it's as good as possible, or it's as good as it needs to be to fulfill?
Well, they're two different things, and it's kind of the essence of the conversation, really. So it's all based around this concept of the ALARA, or the ALARC principle, as low as reasonably achievable, as low as reasonably practical in the UK. And where I think we get ourselves into problems with this principle is we're always driving to a lower number. Like if we think about off-site emissions, for example. Sure. You know, there comes a point where another 3/5 of nothing makes no difference.
Right.
And so I think
who's missing that? Is it the regulator that's missing that, or is it the applicant that's missing that point?
It's the regulator in a lot of cases that is missing that point. The regulator is driving more and more stringent requirements that, because it's this massive emphasis on more and more safety, more and more regulation is a good thing. But actually what that does is it stifles innovation, it stifles deployment times, it makes everything more expensive,
yeah,
etc.
And is this true of all Is this true of all regulators?
I mean, it's true. I want to be clear. I don't want to upset the regulators, because let's be honest. We have an extraordinarily safe industry, and we have that industry because the regulators have learned lessons and have moved things forward and adapted.
And by the way, I actually don't think you'll be upsetting the regulators even if you criticize them, because I've spoken to so many of them that want us to be critical of them because many of the individuals want to change things, but they feel like the inertia of the organization doesn't allow them to. So they actually welcome critical voices to give them more standing to have like internal conversations that challenge the way of doing things. So I would actually not hold back if I were you. Be as critical as you want, and I think they'll appreciate it.
No, I absolutely agree. But I did want to get the point across that I do think they do a fantastic job. And a very challenging job. And you're absolutely right. A lot of the individuals that I've spoken to as well are very keen to change things and very keen to be a bit more progressive and sort of collaborative between different regulatory bodies so that they can learn from each other. And you're absolutely right. The sort of the inertia and all the background within the associations it's turning a tanker ship around, isn't it? It takes a very long time, for want of a better analogy. But it is the regulators, and you know, the regulators need to start having serious conversations about sort of where this is going, because if we keep adding more and more layers, it will suffocate the industry.
Yeah. And I actually don't think it helps them achieve their goals either. If the ultimate goal is safety of people and the environment, I actually think there's a very strong argument to be made that adding additional layers adds complexity. Adding complexity adds risk that the layers are misunderstood, risk that the layers will interfere with each other in an unpredictable way, risk that there's just so much stuff going on that it actually becomes impossible to keep track of it all. And then you miss something and you allow mistakes to happen. And so I think we need to actually have that conversation as well, that more layers can actually be more dangerous, not more safe.
You're absolutely right. The more things you have to engineer, the more things that can go wrong.
Yeah.
And you know, it's the machine that doesn't break is the one with one moving part.
Yeah, I love that. I haven't heard that one, but that's perfect. Okay, so tell me, let's just continue through your career a little bit so we don't lose track.
Right, so we just got to the US with Westinghouse, and so I was there for a year, living in Pittsburgh. Absolutely wonderful experience. Met a very large number of very good friends and colleagues that I still have to this day, both inside and outside of Westinghouse. So that was absolutely brilliant. Really enjoyed that. And then I returned to the UK because Fukushima occurred, and the whole industry went into sort of, you know, it just collapsed in on itself a little bit and recoiled from the world scene a little bit.
Yeah.
So that was sort of the coming back to the UK, and at that point, obviously a lot of the new build was just a little bit on hold. Everybody was sort of looking at what are the next steps, and so that was the point where I decided to sort of make a bit of a career jump and sort of move to Rolls-Royce, a civil nuclear division, as lead engineer, and was part of their sort of business development program to help them build their civil nuclear program, undertake, you know, business development work with various clients around the world and in the UK, looking to win contracts and bids, and some of them they're delivering at Hinkley Point C today. And so I was there for about 2 years. Again, enjoyed it, but after about the 2 year period there, or 2-3 year period at Rolls-Royce, the new build market was picking back up again in the UK, and Hitachi had entered the fray, and they were looking to build and develop a project at Wilva. So So I went and became part of the contract management team for the Horizon project, essentially managing parts of the contract to bring the ABWR to the UK and all of the interfaces that had with regulators, with design teams, with the licensing team that was being run in parallel to the project development team. And so I did that for about 3 years.
And so now you're getting actually quite a bit of different experience seeing kind of fits and starts of outside, like international companies trying to play a role in the UK market, right?
Yeah, exactly.
So at this point, any other lessons learned or patterns emerging that you're seeing about what people are doing right and wrong?
Yeah, I mean, I think the familiar pattern is the regulatory one. Everybody underestimates the regulatory challenge coming to the UK, particularly if you have a design that's already operating, because the cost of change is very high.
Yeah. And why change it? If you that's what I never actually understood. If you already have a design and it's working somewhere, and someone, you know, obviously it's kind of gone through all of the, you know, it's gone through the processes and the inspection, and people have looked at it, and it's really like lived up to muster. Why change the design at all? Why not just go to the regulator and say why the existing design meets their criteria, rather and literally not allow for a single bolt to be changed, and just say, listen, you can take it or leave it. Obviously, other people think this is safe. Obviously, we have a compelling case. Obviously, we have hundreds of engineers that can talk to you about why it's safe in its current form, but we are not changing this design, period, end of story.
It probably wouldn't let you build it.
And why? Why?
That's a really fascinating question, and it's kind of what I'm trying to solve in my job today. You know, a big part of the objective of kind of where I work today is that you can take a standardized design that has been approved by a competent authority and build it anywhere with next to zero change.
And why? And I know we're going to get into this, but why does that actually require any change in policy or procedure whatsoever? Why is that not just something that a few people have a conversation in a room, like a few lawyers, a few engineers, a few heads of government, a few heads of state, and like in one afternoon, they all discuss it. People bring up their concerns, and then they come to the conclusion that obviously, if another competent regulator approved it, it's good.
Well, I think I'll tackle that in various stages. I think the first one is most of the regulators would tell you that they're independent. That would be first step.
Yeah, but independent is supposed to mean independent from like undue influence from like an executive branch, where like maybe like a dictator takes control of a country and says, you build these plants, you know, with cheap parts or else, because my cousin runs the cheap part factory. And then like they're supposed to be like independent and be like, no, you don't control me, but like not necessarily independent from each other.
No, they're supposed to be independent from undue influence from heads of state and or otherwise, right? The main reason I can work out, I don't have an answer as to why it doesn't happen. I'm still trying to look for that answer, by the way. I don't think anybody has that answer, but you're quite right. Just knocking some heads together might be a good idea. Yeah. But I think a lot of it has to do with history. I think, you know, a lot of it has to some extent, from my personal perspective, I think a lot of it has to do with where did the nuclear power industry come from?
Okay, yeah.
It came from you know, the desire to make weapons,
right.
And as a result, a level of secrecy and security and control got built around it.
Yeah.
That then, you know, manifested itself when we started looking at in each individual country started developing their own civil nuclear program for power purposes.
Yeah.
That level of secrecy and security, etc., came with it. And as a result, it's sort of embedded into sort of government and ministers, you know, mindsets that this stuff needs to be protected. And it does need to be protected to a level, but maybe not to the level that we can't have a conversation with some friendly neighbors.
Yeah, and then also just making that distinction clear between weapons and civil. I mean, I just think the distinction is so obvious. You know, it's like you could use a proxy like enrichment level to just make a very clear distinction between the two. Like you can't make weapons with sub 5% enriched uranium. So why isn't anything that clearly is just using sub 5% enriched uranium not subject to the same levels of secrecy and concern?
Exactly, but like I said, I think it's a historical mindset thing, and
I see. You're saying it's cultural. It's beyond logic. It's cultural.
Exactly. That's my personal perception on it, at least anyway.
Yeah.
You know, I think the answer will only come out in the wash once we've actually solved the problem.
Yeah. Okay. So I guess how did you become part of the World Nuclear Association?
Yeah, so that sort of came sort of after I came back from Japan. I was out in Japan for 6 months with Hitachi, and then sort of came back and spent a little bit of time being a project management consultant for numerous sort of projects, delivering projects into Hinkley Point C. And then I sort of had a bit of a decision to make, really, in terms of I realized I could continue to sort of, you know, ride the wave up and down of sort of project development in the UK and come across all of the same challenges and same problems that every project I've worked on to date has come across, or I could go and try and do something about it. And so I looked around, and there was an opportunity with the World Nuclear Association, and very specifically with their CORDEL working group, which is the Cooperation in Reactor Design and Licensing working group. And
can you tell me a little bit more about that acronym? Is there a reason it spells out CORDEL, or is it?
It's titled the Cooperation in Reactor Design and Licensing, and they've just managed to pick the right letters in the starting 2 or 3 letters of each of those words to pick CORDEL. That's all I know about it.
It doesn't, like, I guess just maybe I was thinking like it sounds like cordial because it's like people working together. Is there anything like that, or is that just me making stuff up?
If it is, it's before my time, and then nobody's told me.
Okay, keep going. Sorry.
No, you're fine. So yeah, and very specifically, sort of their standing mandate, as I've mentioned, is to have a situation where you have standardized reactors that you can build anywhere in the world. And so I thought this is a good fit. This works quite well in terms of kind of where my mind is at in terms of what needs to change. So I was lucky enough to get the opportunity to go and work there. And then sort of my focus there is on SMRs, on licensing and permitting, and on digital I&C. So those are the 3 areas that I'm responsible for.
So tell me about licensing of SMRs, and does this change the story at all? You know, some of the things that we were talking about before about how regulators view them. Is SMRs the opportunity to kind of like press the reset button on our licensing cultural expectations?
It might be. So I'll probably answer that in 3 ways. The first one is sort of the association has written a report titled Design Maturity Expectations and Design Maturity and Regulatory Expectations for SMRs. And that looks across a number of countries trying to mesh together the design stages that you go through when you're designing a reactor versus the design expectations of the licensing process in 9 different countries. And it turns out that as far as getting a construction license goes, everybody's relatively well aligned. As far as the pre-licensing processes go, we're not all that well aligned at all. Some of them start very early in the process. Yeah. Some of them start quite late in the process, and there's anything in between those 2.
And what are these countries? Is it, I'm looking at a list right now. Is it Belgium, Canada, China, France, Korea, Russia, UK, Ukraine, USA?
That's the one.
Okay. Yeah. And how did you choose these to look? Because there's probably like 20 more. How were these chosen?
They were the way the association works, and the way our industry corporation groups work is we put out a request to our members that we're going to do, or we're proposing to do this report, who'd want to be involved, who wants to contribute. This is the information we're looking for, and then we get back sort of replies and responses. And thankfully, we had quite a lot of contributors to this report, so it was quite well detailed.
Yeah, no, it's amazing looking through it, and I'm really glad that you guys put it together. I actually think certain reports are better than others in terms of clarity, and I think this one hits the nail on the head, so to speak. So
well, that's good to hear. Thank you.
So
a long time formatting and writing it.
Yeah, I think that's important. And then so I guess I want to ask this question, but I know you can't answer, but I'll ask it anyway. Why doesn't everyone participate? Like, I don't get it. Like, why doesn't literally everybody jump at the opportunity? Because it's like, it's a World Nuclear Association. It's not like, you know, some gotcha organization. It's like, it's going to be helpful to have, it would be helpful to even see yourself in comparison to others. Like, it's free education for yourself. Like, why wouldn't everyone participate?
No, absolutely. And that's very much the premise of the way the working groups and task forces are set up, is that it's freely publicly available information, and it's for everybody to contribute to and learn from. And so I can't answer as to why everybody doesn't necessarily get involved. I know it from the other side, as in having worked in organizations that contribute to the World Nuclear Association, is that there's always slightly different time pressures. So you're always up against the clock on something, and then to take on something else that might be another, 2 months on and off work might be a bit of a challenge. That's certainly a factor. But it's not the only factor. And so it's an interesting question, but not one I can definitively answer.
And do you think that now this report has come out, that there's an opportunity you can send it back to everyone who didn't participate and say, hey, we'd love to do an addendum. Now you can see everything that's going to be in it. Like, will you now contribute? And then we'll come out with another one in 6 months or something that has everybody.
Well, so to be honest, and just to sort of get back to your original question about sort of is SMRs the opportunity to reset the licensing button, it's for us, it's more about kind of the next step. It's kind of, we've sort of done this report. The level of detail about the countries is really interesting, and it's really useful. But for us, really, it's about kind of how do we take those recommendations about sort of international cooperation and bringing sort of regulators and industry and government closer together and make that work. And so that for us is the bigger thing. If the opportunity came along and other contributors wanted to add to it, we could absolutely do addendums. That wouldn't be a problem. It would certainly add to the weight of the report to have other countries involved. But really, for us, it's about what do we do next? How do we sort of move this to the next step? Because the licensing challenge for SMRs is, to some extent, it's even worse than it is for PWRs, because we have the risk that things will diverge even further. If you separate SMRs between sort of light water reactors and the Gen 4 concepts, the light water reactors will probably have similar challenges when moving between countries as we've seen so far. But the Gen 4 concepts, if you pick for example, a molten salt reactor, some of the countries listed in that report won't have any experience of it. Mm-hmm. So then they're going to have to go and find something if they want to use it, and then there's a risk that diverges even further from sort of the other countries that are also reviewing molten salt reactors. Mm. And so it's utterly urgent that we start to bring this together in an international forum and get people thinking about how do we come up with an approach at an international level that can satisfy everybody from a regulatory safety standpoint, and also can actually help both the mature nuclear countries deploy reactors faster, but also help developing countries who don't really have the regulatory frameworks to pick up some of these technologies and utilize them.
And when you say, I want to be precise when you say the developing countries. Do you mean the developing countries that don't have nuclear, or just don't have as many nuclear plants as the bigger countries do?
A bit of both.
Because one of the things that I want to hear your thoughts on this. One of the things that I've been considering is actually the nuclear countries that have a nuclear reactor, but don't have like a giant entrenched industry, don't have like incredibly entrenched like cultural values also in their regulatory scheme, might actually be the best pioneers to lead the way, which sounds a little counterintuitive. You think, okay, maybe you want the most resourced countries, the most ones with the most experience, but it's like, let's take a small country like, the Czech Republic or something. They're extremely competent. Like, they've got great nuclear engineers. They've got, research reactors. They've got, a couple, commercial reactors. Is it possible that they're actually far better positioned to lead a new regulatory paradigm than a country that has, 1,000 stakeholders in their licensing organization?
It's certainly possible. But in order for that to happen, it's very much, I sort of see the first step to that process being that we get ourselves comfortable, and when I say we, I mean the sort of international nuclear community, get ourselves comfortable with the idea that the Czech Republic or another would take the design of a SMR that has been licensed in the US, Canada, the UK, France, Russia, wherever, and essentially just does the site licensing activities required to sort of look at the seismic spectra, et cetera, to then build it on their site without significant changes to, core design, et cetera, and all the stuff that costs a lot of money.
Yeah, I mean, that's a no-brainer to me. Like that's just general reciprocity, right?
Exactly. So that's what makes a lot of sense, and that to me is I think is the first step towards this new regulatory paradigm, because then if you can get that done, you can then bring in other regulators to sort of look at that and sort of go, okay, there's a model here now. This is maybe a way to go, and then you start to build and develop trust between sort of how those activities are happening, and then all of a sudden we have a process that we might be able to harmonize.
But don't we have historical precedent for this? I mean, I went down to Mexico and met with the regulator down there, and I forgot how many people they have there. Maybe, I don't know, like 100 or something. And they have a GE reactor, and I think their basic premise was, yeah, we're not going to ask GE to redo their reactor, like a BWR. This is like from the 70s, 80s, 90s, whatever it was.
Sure.
And they're like, yeah, we're not going to ask for any changes. We believe that the US did a good job. And so we're here to make sure that the continued operations kind of meet standards, but we're not going to ask them to redesign their reactor. I think that's how.
Yeah, I mean, there is. I don't know the specific case in Mexico, but there's definitely precedents for it, and there's also precedents, in Europe, and where some countries will have their, particularly in Eastern Europe, will have accepted the Russian regulatory sort of findings and have moved on to construction on that basis. Others are less willing to do so. And again, that's sort of part of the mindset challenge that I believe we have to move past and get on to a point where a competent authority is deemed a competent authority because they are just that.
Yeah, exactly. Okay, so let's get action oriented here. What do you think literally needs to happen to move forward on that?
Right. So then this is the other report I wanted to mention was CORDEL produced what's called a lessons learned from transport report, because believe it or not, the nuclear industry has actually managed to harmonize regulations previously in association with transport. It was one of the first activities the IAEA really did.
When you say transport, what do you mean transport? Transport of what?
Transport of fuel, transport of new and spent fuel. We do it
of new and spent fuel. Okay, interesting. Because I would imagine those would be two wildly different cases. It's like new fuel isn't radioactive.
Yeah, I mean, we have, you know, what is it? I'll probably get this wrong, but the Type B package containers that are, you know, universally accepted for transport of sort of spent fuel around the world. There are local challenges to it, etc. But fundamentally, the regulations are harmonized at international level. They're ratified by, you know, every country, and there are no changes in requirements as you move from one territory to the next territory.
Okay.
And we've been doing this since the 1960s, basically. And so there's a large amount of precedence there in terms of something that we can do properly, and we can harmonize.
And okay, so yeah, you're using the word harmonize, which actually scares me a little bit. I like the word reciprocity better, because reciprocity means that you can actually have two different systems, but you trust the other system and you can go with either. And that makes it actually easier to get things done. With harmonizing, and maybe this is just the words and coming back to our English, I'm afraid whenever I hear harmonizing, because the first thing I think is, okay, everyone has to get in a room and agree on a common set of standards, and that's impossible. And then that common set of standards, there's no guaranteeing that's going to be the best. Like, you know, that's going to be the best, like, final outcome. I mean, they're usually called compromise for a reason.
Yes.
And it might be overly conservative, and it might make it harder to get things done.
No, you're absolutely right, and you raised a really good point. And harmonize, the word harmonize scares a lot of people. And I'm using CORDEL's language because that's what they have traditionally used. What it really means is a harmonization of approaches, or a streamlining of approaches. Is in terms of we're not talking about what we definitely don't want to happen. Is everybody get in a room and agree that the most strict requirements are the ones we're going to follow, because that race to the top is just going to kill everybody.
Yeah, exactly. That's a good way to kill the whole industry, as if it's not already dying. Yeah.
So that's the one thing we definitely don't want for people to understand by harmonization. What we really mean is that there is an agreed approach, and I'll let you say that word.
Reciprocity.
Reciprocity, that's the word. Yes, thank you. So that's quite a good way of thinking about it, because it means that one regulator can accept the output of another regulator's review, and or they can do separate bits of a review and come together and share conclusions, so that there is one whole part. And that is kind of really what we're trying to drive at. So that it's not everybody getting in a room and agreeing a set of requirements, because that will never happen.
Yeah. Okay, so back to my other question. Literally, what do you do to move this forward? Do you host a conference? Do you get two people in a room and then add a third person? Like, what do you do to make this move forward?
Yeah, so what we've proposed is the development of it's a long title, a multinational advisory panel, which essentially is constructed of competent regulators. And by competent regulators, I mean, you know, the big sort of regulators who've been doing this for 40, 50 years, representatives from them, and they have a mandate from government to essentially dictate and control sort of the activities associated with licensing of reactors around the world. And it might start off quite small. So it might start off with maybe, you know, 2 or 3 regulators coming together and working out how they're going to review the designs of a number of SMRs. That then might expand to getting, you know, you might get a 4th and a 5th coming in for the second set of reviews, and then you get 6 and 7 coming in for the next set of reviews. And ultimately, you build a repository of all these designs that have been reviewed and accepted by this panel and group of regulatory experts that have a mandate from their governments. And the mandate from the governments is the important bit, really.
Does that mandate come with money? Is that the idea, or?
It has to come with money,
Yeah.
Because regulators have budgets for international collaboration, but they don't have budgets for this scale of international collaboration.
Yeah.
This is they're going to need more people, basically.
And when you say, so they come together and they approve design, what exactly are they approving in these designs?
That's sometimes the challenge, is in terms of what are we actually going to look at? Because when we think about licensing, you know, in the and I'll go back to the US and UK as two very different examples. In the US, you approve, you know, if you think about the design certification process or the standard design approval process, you approve a design, you know, essentially the NSSS and supporting systems. And then you can move then into sort of your call application or your site license application. In the UK, you don't really approve the design. Your license application is for a site, and then activities within that site. Now, obviously, the design has a huge influence on that, but it's fundamentally slightly different criteria. So actually, one of the first things they have to get together and agree on is what is it they're going to review and what does that mean, and how it. But it's kind of part of that. Part of what we're trying to develop now is kind of how do we take what they're going to review, and it's not about all of a sudden, you know, this isn't about taking away regulators' national sovereignty either. This is about them being part of an international panel that reviews designs. There will then be, in theory, a process that takes that review and puts it back into their regulatory process. It just skips most of the front end and gets to the back end where you can apply for site license.
But how much staff would this organization have? Because it's like, you know, I've seen what NewScale had to go through, you know, like 10 years, you know, they say 4, but it's like 10, $500 million worth of work. And this is for a very well characterized technology and a giant bucket of water. Like if it took them all of that time, resources, effort to get, you know, approval, how could this new organization possibly have the resources to license advanced, quote unquote, advanced designs that are not as well characterized as just a small PWR?
No, and you're right. And resources are problem. The initial intention is that you know you would reach back into existing organizations. You know, you reach back into the ONR, reach back into the NRC,
I see, and borrow people and borrow expertise. Yeah,
borrow people and borrow expertise, and actually, you know, some of a big part of the concept behind this is the working collaboratively and the development of trust.
Yeah.
So if somebody from the NRC or from the ONR can work alongside somebody from the ASN in France and understand how they're doing the review process, such that they understand why they've done what they've done, they've understood what the output is, and they understand the implications of that, then that collaborative sort of working develops a level of trust that then when a design comes out of the French regulator, it's a much smoother path through this process, because there's less checks and you don't require as many checks and balances, because you get to a point where everybody in the room knows what everybody else is doing, and that unfortunately takes time, and effort and resource.
Yep, and then. Yep. And then this might take a while to actually get spun up also, right? Or do you think that there's a pathway to make this happen next year?
There's not a pathway to make it happen. Let me rephrase that. There is a pathway to make it happen relatively quickly. The challenge is the government funding. You know, if you just going back to, like, if you speak to regulators are generally quite keen to have more international collaboration. They are keen to work together, and they're keen to sort of learn from each other and take on board what they can do. It's how do we make it happen? How do we fund it? How do we get governments interested in making this happen? That's kind of where some of the challenges.
Can I ask a question? This might just sound insane, but you tell me. Given how important moving nuclear forward is, and I think everyone in the nuclear industry internalizes that, and they also kind of see what's been happening these last couple decades and know that things are not going in the right direction. So given that, also given the pending climate issues and just like general clean energy and energy poverty issues that we know nuclear can solve, is it so crazy to ask people to volunteer 20 hours a week? Like, I understand it's a lot of time. They're working 40 hours a week, and now I'm asking them to work 60 hours a week. But is it so crazy to ask for volunteers across the world to commit to 20 hours a week for 2-year stints or something, and just say, I'm going to buckle down and I'm going to do this, and form a volunteer corps of 2,000 people, in the next few months that are just willing to do it, and then just say, this is too important. I want to leave, I've got kids. I want to leave a legacy of having moved the world forward. I know nuclear technology is going to be absolutely pivotal in doing that. And this is just my duty as a nuclear engineer to volunteer my time. Is that crazy? Is that insane?
No, I don't think it's entirely insane. I don't think you'll get the numbers you need. I think you will get, some extraordinarily dedicated individuals who would be willing to do it, but I don't think you get the numbers required. I think one possibility might be, and there's always been a question around what industry's role in this is, because this multi-advisory panel sort of sits in the middle of industry, regulators, government, basically. And so we understand what the government's role is, we understand what the regulator's role is. There's always been a sort of a question around what can industry sort of do to help move this forward. And maybe there's something not too far from your suggestion there about where there are lots of extraordinarily competent safety engineers in industry, and it's not beyond the realms of imagination that maybe industry can provide some of those highly qualified safety engineers to this on a sort of a rolling 1-8-year basis, 18-month basis, etc., as part of a secondment program, etc., etc. That I think is a possibly more realistic route of getting the numbers we need.
Industry, yeah. I'm just trying to think of which companies though would actually do it. And the problem is the largest nuclear companies that have the people and can afford it are also generally the most conservative, and also kind of, I feel like they're just like, they're dying for a reason. And like, I'm afraid, yeah, I don't know. Maybe when you say industry, there's more medium-sized organizations that would be up for the challenge.
I straight off the top of my head, I was thinking more of some of your engineering consultancy organizations.
I see, like a Jacobs or one of those. Yeah.
Something along those lines that they have extremely competent people all over the world, and there might be there's obviously something, there's a level of incentivization there for them as well to actually do it. I understand what you're saying, but it's a challenge, and we have to find the people somewhere. Because I guess here's the thing: if we're serious about trying to solve climate change, and we're serious about doing that through the development of nuclear power, which I believe is the only way we're really going to do it in time, then we have to find a solution to that. And there are lots of roadblocks, there are lots of problems. But we have to find a way through those, and we have to do it sooner rather than later, or I'm going to be sat here in 10 years talking to you, just telling you that we haven't learned the lessons from the deployment of the Gen 3 reactors, and we made the same licensing mistakes as we did with the SMRs.
Yeah, well, I think at that point, we might as well just all give up and go home, because I think what nuclear has going for it right now actually is the climate message. I mean, it's always had the clean air and energy message. But I think that what's really kind of gotten like more broad support outside the nuclear industry is the climate message. And in 10 years, we're either going to be at a tipping point where, we have like, there's a clear solution in sight, or everyone just gives up because it's like literally too late. I mean, it won't be like it won't be like the oceans are boiling then, but like the math will show at that point that there's no going back. So I think we have to move quickly, or just say we don't, or just like admit we don't care. Like,
yeah, we kind of have to do one or the other, don't we? We definitely have to get off the fence.
Yeah.
But no, it's
cool. Please, no. So just tell me more about, like, let's just switch gears for a second. Tell me more about just what you see happening in industry that makes you optimistic, not industry, but just like the nuclear sector in general that makes you optimistic.
I think this is, I definitely think the advent of the amount of energy around SMRs at the moment, and around the timescales and deployment and the ambition of all of the companies that they're bringing to the table, and the enthusiasm and the energy they're putting into the sector at the moment is absolutely fantastic. I've never seen anything like it in the 13, 15 years I've been in the industry.
Yeah.
So that's really exciting. It's quite empowering, and it's good to see that there's so many people engaged and there's so many people interested in what it's doing. And I actually think that's helping to drive a little bit of sort of cultural change and changing the conversation a little bit around nuclear, because there's a lot more people who are peripherally or actively involved in the industry at this point. So that's quite positive. The other thing that's quite exciting is the amount of work that we are seeing regulatory enthusiasm about working together. We are, there's been signs with the MOC between the US NRC and the CNSC in Canada, who are jointly working on some reviews of SMRs, and CNSC have also signed an MOC with the ONR. So it looks like there might be some joint work there at some point in the future, hopefully as well. So that international sort of collaboration is starting to take some sort of shape, and it feels a little bit like we're at a tipping point with it, where we sort of need to kick it into the next gear and then see where it takes us, or it will sort of settle itself back down again and it won't go anywhere. So that's kind of exciting that we're trying to drive that at the moment.
Allan Carson, everybody, thank you so much for taking the time.
Thank you.
And initiate at least a new approach to the many difficult problems that must be solved in both private and public conversation if the world is to shake off the inertia imposed by fear and is to make positive progress toward peace.